thì có hai cái là muốn nói. Thứ nhất là đây là khóa học high tech, cho nên là bọn này muốn dùng rất là high tech công nghệ, sẽ dùng phấn đen, phấn trắng và phấn đen. Và sẽ okay, so let me start the course by giving you really try to motivate everyone. Why should we learn digital signal processing? Right? So just very short introductions and overview of the field, right? Of the field DSP. Okay. So before we understand what is DSP, let's try to understand what does each word mean, right? So we start by signal. Signal really means any physical entity that carry information, right? So anything you see outside there in the real world that carry information, like what I'm talking right now, carrying that signal, the speech, getting to the ear, that is a signal, right? The weather temperature is another type of signal. The video trying to recording me now is another type of signal. So you can see the signal is everywhere, right? Processing is quite obvious, right? It is simply a series of steps that try to accomplish a particular end, like a purpose, like what my mind is doing right now, trying to capture this image signal, and my brain is really processing and trying to really recognize the people in this room. Okay, so signal processing is everywhere. Our brain, our systems, our society doing signal processing all the time. Okay, so you can see the impact of that field. Now, digital, what digital means, it is simply mean that signal processing is done by a computer, simply put, right? Because digital is thing that can be done by a logic circuit. So digital signal processing is an area that we use computer to do the processing of the signal, which is anywhere around us. Okay, so everyone understand that? Okay, wonderful. Okay, we move on. So I'd like to put an example here of speech recognition. Something, even a child can do it easily, right? You tell the child something and see or he can, understand it. And we use speech recognition every time to acquire our information and carry our daily life. So how about the speech recognition done by a computer? So it would say something and that going to give you some signal for you to process. You can record it by a microphone, right? There's a microphone with a camera, and that signal, typically the electrical signal, get converted into a digital form, right? In computer, the only thing it can carry is the digital, right? The signal in the digital form, and we will talk more about that. And then there's a whole processing here, which is a lot of mathematical algorithms, a lot of techniques, right? A lot of computer algorithms running inside that, and do what our brain would do effortlessly, right? All the time, and turn out what is that information is carrying. Okay, so that is an example of digital signal processing put in place. Okay, so everyone understand that? Okay, good. So let me put another example, and this one would be taught intensively later on in the third course, namely compression. Compression is a multi-billion-dollar industry in the US. It's multi-billion dollars, very, very big industry in the US. Think about it. The internet wouldn't be able to be around this day without compression. Why? I have an image, I capture an image, and I talk more about that later. But typically, it's about, typical image about 3 megabytes of data. Okay, 3 megabytes of data, huge. And any of you here have experience downloading, web page of the internet? Raise your hands. All right. I should see everyone raise their hands, right? Okay. It would take forever, and we wouldn't be able to see all the image, and the web page. Now, with the compression technology, we can break that file from 3 megabyte to about 19 kilobyte, about almost 200 times compression. So instead of spending 200 seconds, right, so 3 minutes, you can see that the image within a second. So you see that the internet the DSP and this, and we talk more about that, and that's a whole course will be devoted to that. To show that how can I take this information and I do digital signal processing, get it to some file in a very small form, and then transmit very quickly through the internet and download and display the outcome. Yes, you have questions? Okay. Using something very latest development. Normally now you have on the internet jailbreak, but the new technology called jailbreak 2000 based on wavelengths. So that is the second course. I can see the big improvement. The same amount of file that has different image quality here, and there will be a whole course showing you what is amazing behind this. Okay. Let me show you another example of digital signal processing in place. So, anyone here have a digital camera? Raise your hand. Okay, quite a few people. Who used the old camera before? Okay, a few. Okay, so you are pretty young generation, right? We use, if you remember, you have those old camera, film camera, very, very big. And the major emphasis is on the physical property of the camera. Right? You have a very good lens trying to capture the information. Now, the digital camera appeared in the market about 5 or 10 years ago. And really, people put a lot of effort into the DSP, right? The new mathematical algorithms, the new computer algorithms, the new signal processing techniques that really can convert some image you take that has some problems like this or that, right? You see a lot of those. For example, you take an image, there's a black line. Then we can do some very simple signal processing and can turn an image into a very much better quality. So you can see that we use computer power, right, computational power to improve the quality of the physical system. Okay. Everyone understand that point? Right? So that will be the major theme of this DSP, and we come up to it later more and more. Another example that is great, but I want to show you the cutting edge resource now on this. So, anyone have one of these cell phones that have a camera on it? Right? And how do you have it? And you know that the cell phone people want to make it very small. Right? Very, very small. And you want to put a lens there. And the lens is very small, right? You cannot make a very big lens. So the image you have nowadays from one of these cell phones are very poor quality, and nothing you can do about that in the physical side, right? Because the camera is very small. So the people now trying to do it, they put a lot of DSP power here. There's a big microprocessor inside that cell phone, and it really crank out the number, doing all the mathematical calculations, and it turned out a beautiful image has come from a good camera. So that is really the cutting edge research now. A lot of